Okay, so let's discuss about internal one paper. This is divided in parts where a case study is given based on complaints. We have to classify IPC and BNS section mapping, and the part A consists of statistical characterization of complaint data, right? So we are given questions, different questions, and according to that, we will discuss and analyze about it, right? So first question is, give three commonly used statistical measures to characterize dispersion and complaint derived scores: alleged offense severity, evidence strength, harm impact index. Discuss how these measures can be computed efficiently over large complaint repositories. Example: partition store, streaming aggregations, and approximate sketches. Right. So let's discuss about it. So we want three measures of dispersion for statistic measures for our complaint dispersions, right? So our first dispersion method is standard deviation, which measures the spread around the mean. Second is interquartile range, which measures spread of 50%. And then we have median absolute deviation, which is more robust metric for spread around median, right? So these three methods we will discuss, and they are often used for indexes or the matrix which are used to evaluate our classifier or classifying reports, right? So let's discuss about it. First method is standard deviation. So for standard deviation, we first compute the mean, then we compute the variance, and then for standard deviation, we take under root of variance, right? So for in the large streaming area or where data is real time, we can compute and store count, sum, and sum of squares like runningly. And for efficient, if a query comes, then the running sum or the running count sum of squares, these are stored, and based on that query, the complaint is evaluated. So these are the formula given, right? Now second method is interquartile range and MAD. Interquartile range is often used for outlier detection, where if the data is beyond the quartile 3 and below the quartile 1, then it is said to be an outlier, right? So we will study about this. Interquartile range is calculated using quartile 3 minus quartile 1. And quartile is basically we are dividing data into into three equal parts and four parts, right? Into three section and four parts. Quartile 1 is basically 25th percentile, quartile 3 is 75th percentile, and then MAD is calculated using median of xi minus median of x. These can often be used in streaming and partition data system with quantile sketches. We can use a quantile plot or QQ plot for this sketches, right? So this covers our first question, where we discussed about complaint repositories, partition stores. We can use a data warehouse and ETL jobs for it, right? Now let's discuss question two, which is we are given evidence strength scores from 1 to 100, and these are all sorted values. We are asking mean, mode, mid-range, quartile 1, quartile 3, 5 number summary, draw box plot, and how QQ plot different. Okay. So let's discuss this. We are given this data set where you will count the values. It will be 27, right? So we will apply the formula mean, that is sum of all observation upon number of observation. We will get a value as 29.96. We will calculate median, which is 27 by 2 is basically 14th value. It will give you this. We'll check the data set. Oh my bad. Check the data set most occurring values. We will get 25 and 35 as occurring values, most frequent occurring values. So we will get mode as 25 and 35, right? So now let's calculate mid-range, quartiles, and 5 number summary. Mid-range is calculated using the least value plus the maximum value by 2. So the mid-range will be 41.5. Quartile 1, which is 25th percentile. Quartile 1 formula is, let me write it here. Cannot write. Okay, I'll say formula is n plus 1 into 1 by 4. Quartile 2 formula, which is same as median, n plus 1 into 1 by 2. And then quartile 3 formula is n plus 1 into 3 by 4, right? So After finding the quartiles, we can generate five number summary, which is minimum number, maximum number, quartile 1, quartile 2, and quartile 3. This is the five number summary of any dataset which can be given, right? And we will plot a box plot for this. We have box plot. This is the quartile 1, this is quartile 2 or median, this is quartile 3, and this is the interquartile range. This range from this to this, right? Here we could see there is only one outlier, that is 70. The evidence, what was evidence strength score? Only one evidence strength score was an outlier which can be detected using box plot, right? And we can see that the data is distributed in the right side, so it can be said as a right skewed distribution, where our most of the data is skewed right skewed, like, and we can see that outlier is too high and it is the maximum value. So yeah, we could conclude about this, right? This was all for question 2. Now let's see question 3. We are given severity index distribution, which is built from extracted complaint feature. We are given severity index 1 to 5, frequency are the cases. For 1 to 5 severity range, we have 200 cases. For 6 to 15, we have 450, and so on, right? And we have to compute an approximate median severity. So it is asking for grouped median, right? So it is very simple. We have formula. Let me show you. We are given this data set where this is the severity index and this is the number of cases, right? So first we will calculate the total number of cases, which is after summing this up, we will get 3194. Now we will take n by 2, which is 1597. We will take median class, that will be 21 by 50, this one. And mm, we will take the L, which is 21. We will take cumulative frequency for all this data. We will take cumulative frequency, and for the median class, the cumulative frequency would come out to be 950, right? And we take F, we take H, which is lower limit. So lower limit plus n by 2, it is class size. So after putting these values in the formula, we will, after putting these values, we will get the approximated or the grouped median as 33.5, right? So this question is also completed. Now let's see question 4. A district intake sample record complaint, age, and self-assessed incident impact percent for 18 complaints. So we are given different ages and we are given their impact percent of the complaints. Now we have to calculate mean, median, and standard deviation for age and impact percent. We have to draw box plots for both. We have to draw scatter plot and a QQ plot to study the relationships. So let's go on this one. So we are given this data set. We are given age column. We are given an impact percent column or feature. Now first let's calculate the mean. We'll calculate the mean with this formula and standard deviation with the formula. So mean come out to be 46.44, median come out to be 51, standard deviation come out to be 13.22, impact mean and median and standard deviation, all this come out to be for impact percentage, mean, median, mode come out to be this, right? Now we will, with this knowledge, we can calculate box plot where Q1, Q2, Q3, we will calculate Q1, Q2, Q3 with the dataset and you will get this box plot, right? So from this box plot, we can see that the there are no such outliers, right? And yeah, this is it. For box plot of impact percent, this is it. And we can see two outliers below 10, right? Box plots are generally used for outlier detection. Here we can see that this is the interquartile range and these two people are out of the interquartile range. So these are generally considered as outliers. Here we can see there are no outliers such, right? Now let's see QQ plots for impact percent. The QQ plots are often uh, plotted on the x-axis we have normal distribution and on y-axis we have feature. So we can see that most of our uh, most of our data is normally distributed. So when data is normally distributed, you can apply parametric models which make assumption about the data. So this data set is safe for applying parametric models. QQ plot tell us this, right? Then we have scatter plot. Scatter plot, as we can see that majority of our data is here, and then we have this some data. So on this of majority data, we can say that this is impact percent on y-axis and this is age on x-axis. So we could say that from this scattered data, that majority of old age people or older complaints have a higher impact percentage. As you can see that older age complaints have a higher impact percentage. From scatter plot, we can tell this, right? So that's it. I hope you understand the relationship between data. From relationship between data, we can draw QQ plot for checking if parametric models can be applied. We can upload scatter plot for checking the relationship. We can plot box plot for outlier detection. And so, yeah.